Okay, so the last video is on mole to mole conversion using stoichiometry. So again, stoichiometry is just where we use the coefficients of a balanced equation. So last time we went mole to mole, this time we're going to go mass to mass. So the coefficients in an equation, so let me go ahead and copy this equation back down. It was NH3 plus oxygen makes water and nitric oxide. Okay, and the coefficients were, let's see, 4, 5, 6, 4. Again, the coefficients are just what balance the equation. But it's important to realize that these coefficients, all of these numbers, they can only be like molecules. So a molecule would be like just like a piece, okay? Like an atom, a compound, a molecule, any of those, okay? Like a piece of it. Or it can be mole. The reason it can be mole is because mole is just a lot of pieces. Okay, what it cannot be grams or liters. Okay, the reason for that is because grams or liters, both of those are not measurements of pieces. They're measurements of so gram is like a weight. So it's a measurement of weight, and liter is a measurement of volume. So neither one of these is measuring individual pieces. It's measuring how much those pieces weigh or how much volume the pieces take up. Okay, so those numbers, those coefficients in front cannot stand for grams or liters. They only stand for molecules or moles. So when we are doing mass to mass conversions, we're going to be going from mass of, so like up here, mass to mass, we're going to go from mass of A to mass of B. So like mass of substance A to mass of substance B. And to get there, we kind of have to go back to moles of A so that we can go mole of B. And then we can go grams of B. Okay, so this is our general path. Let me write it down here. So say I give you mass of A, substance A. And I'm asking you for how much mass of B will either be used or formed, just depending on if I'm talking about reactants or products. I can't use the coefficients to go straight from mass of A to mass B. There's no clear, direct path. But what I can do is go mass of A to mole of A. Okay, how do you go mass to mole? This is using molar mass. Okay, so this is grams per mole, found from the periodic table. You go mole to A. Once you're in mole A, you can go mole B. Okay, the way we do that is doing a molar ratio. Okay, I don't know why I put a little dot on that. Okay, right here, this molar ratio, this is where you use the coefficients. Okay, so you're going from mole of A to mole of B, and once you get to mole of B, then you can go to mass of B. Again, this is just molar mass of B, because up here it was molar mass of A. Okay, so that looks confusing, but it's the same step every single time. Okay, so you go use the molar mass, you use the mole ratio, and then you use the molar mass of the second substance. So let's work a problem. So we're going to work with the same equation that we've been using, but now I want to know how many grams of water, so H2O, produced if 45.4 grams of ammonia, I don't know why I can't write today, are combined with excess oxygen. Okay, again, the whole combined with excess oxygen, that is just to tell you that the equation we're using is NH3 plus oxygen, and then we're going to get water out plus nitric oxide. And the coefficients for that is the same every time because it's just a balanced equation. Okay, so really the only thing, two things that we're working with, I am starting with 45.4 grams of ammonia, and I'm asking you how many grams of water you have. All right, so the path for this is going to be grams of ammonia to moles of ammonia. And then once we're in moles of ammonia, we can go to moles of water by using the coefficients. And once we are there, we can then go to grams of water. All right, so it looks complicated, but every single time you're going to stay with this same format, okay? And like I've told you, you will always start with what you're given. What you're given is 45.4 grams of NH3, and you will work your way to your goal. Your goal is grams of water. So let's start with what we're given, 45.4 grams of NH3. Let's take it step by step just because it'll be easier that way. So your first step right here is to get to moles of ammonia. So since grams is on top, I want to put grams on bottom. Now what I know about grams of ammonia, I know how many grams are in 1 mole. Okay, this is the molar mass. How do you find that number right there? You break up the compound. You say I have 1 nitrogen and I have 3 hydrogens. 1 nitrogen, 3 hydrogens. Each nitrogen weighs 14 grams. That came from the periodic table. Each hydrogen weighs 1 gram. So when you find this, it's 14 and 3 added together is 17 grams. So this number is actually 17 because it's 17 grams per 1 mole of ammonia. So that cancels gram with gram, and you're left with mole of NH3. If you put that in your calculator, it gives you 2.67059. I'm going to keep all of those numbers because I'm in the middle of this problem right here. And so until I get to the very end, I don't want to round. All right, so this is step 1. I'm going to highlight it so you can know where it is in our path. All of that is step 1. So we are now in moles of NH3. Well, the next place that we need to go is moles of, we need to get to moles of water, okay? Moles of water. So we're going to take this number, 2.67059 moles of NH3. Okay, that is where we are right now because that's what we solved for. And since we're trying to get moles of water, we're doing a mole-to-mole conversion of ammonia to water. When we do mole-to-mole conversions, we are going to use these coefficients, the one that goes with NH3 and the one that goes with water. So down here, NH3 is on top, so you want to put it on bottom. Okay? Where am I trying to go? I'm trying to get to water. So then you go back and you look at your equation and you see 4 is with NH3 and 6 is with H2O. Okay? Some of you like to keep it like that. Some of you want to write mole. Either way is fine. That cancels out mole of NH3 with mole of NH3, and I'm left with mole of water. Okay? So when you solve that in your calculator, you get 4.00588 if you keep all those same numbers. Okay, so that is step number 2, where you are going from moles of NH3 to moles of water. All right, let's just go back and look at what we were asked for. We were asked for grams of water. We are currently in moles of water. So we need to go one step further. Okay, so let's change colors so it'll be clear for you guys. Let me do green, why not? All right, so what we're doing is we are trying to do that last step, grams of water. So this is our new given, 4.00588 moles of water, okay? I'm trying to get to grams of water, so since mole is on top, I'm going to put mole on bottom. Okay? I'm trying to get to grams. So moles to grams, this is the molar mass. Okay, so what I'm saying is how many grams are in 1 mole of water? Okay, define that. You just take hydrogen and oxygen and you separate them. And you say, I have 2 hydrogens and I have 1 oxygen. Each hydrogen weighs 1 gram. Each oxygen weighs 16. So 2 times 1 is 2. 1 times 16 is 16. Add those together and you get 18 grams per 1 mole. So this 18 goes up here in this number sign because that is the molar mass. So then mole of H2O cancels, and you're left with grams of H2O. I'm going to write my answer right here because I can't fit it over there. So when you do the math for all this, you get 72.1 grams of H2O. Now we are done. How do we know we're done? Well, there's multiple ways you can tell. I'm finally at grams of water, and I was asked for grams of water. Okay? I'm also at the end of this 3-step method of going from grams of A to grams of B, this mass to mass conversion. All right, so those of you who prefer to do it all in one step, I'm just highlighting so that you can see everything. Okay, so if you look, we did 3 steps. We did grams to moles of substance A, moles to moles of substance B, moles of substance B to grams of substance B. Okay, those are our 3 steps. Those of you who like to do it all together, you don't have to do all of these steps separately. You can start here. You can start with grams of, you can start with what you're given. And you can work to your goal without doing all of those steps separately. So that would look like this. 45.4 grams NH3. Grams of NH3 is on top, so I'm going to put grams of NH3 on bottom. What I know about grams of NH3 is 17 grams is equal to 1 mole. So this is our molar mass. So now grams cancel and I'm in moles of NH3. I'm trying to get to grams of water, so I need to get to moles of water first. So when I have moles of one thing and I'm trying to get to moles of another, I'm going to use the coefficients from the equation up here. So I know that it takes 4 moles of NH3 to make 6 moles of water. So then mole and mole cancels, and now I'm in moles of water. Well, I was asked for grams of water, so I'm just going to go 1 step further and say mole on bottom, gram on top. I know that 1 mole of water weighs 18. Why can't I draw? Wow, that's bad. 18 grams because of this right here. So then mole of water cancels with mole of water. And if you notice, all I have number, unit. Okay? Number. So there's only 1 unit left. So what you do is you're going to take 45.4 times 1 times 6 times 18. All of that divided by 17 times 4 times 1. Your answer should be 72.1 grams of water. Either way you want to do it, I'm going from grams of substance A to moles of substance A. Moles of substance A to moles of substance B. Moles of substance B to grams of substance B, and that gets me where I'm trying to go.